Hello students, this is Mr. Allen, and today we're going to look at area. We're going to find the area of parallelograms, triangles, trapezoids, rhombi, and kites. So let's start with a parallelogram. Now you'll notice here I've actually got two formulas. Oops. I have one formula for the area of a rectangle, and then the more general formula for the area of a parallelogram. It turns out that the two formulas are essentially the same, because a rectangle is a parallelogram. And it's simply base times height. So the base is the base length, and the height is the distance between the bases. So I've got my calculator here to help me answer these. So if I want to find the area of the parallelogram here on the left, I'm just going to say that area is equal to B times H. It looks like B in this case is 5, and it looks like H is 4. That's the height. This is not the height. So it's simply 5 times 4, which is 20. And so it would be 20 inches squared. That's your answer. Now for the example here on the bottom, the base length is 2, and the height is 3.5. This 4.6 is just the length of that other side there, but since that distance is not perpendicular to the base, it doesn't count as a height. So just to make a note here, the height has to be perpendicular to the base. If we go back and look at our formula in the previous slide, you will see that that is indeed the case. So the area here is going to be 2 times 3.5, which is 7, and it will be centimeters squared. So that's how much area that parallelogram will cover. Now, we've got an interesting little problem here. They're asking us to find DE to the nearest tenth. So we've got a lot of information here, and here's how we're going to approach it. We're going to find the area of this parallelogram, and then we're going to use that information to find the length of DE. I'm going to erase everything I have written. Oops. And first, let's find the area. And the area, again, is base times height. And I'm going to use this base and this height. Now notice that the base is the length of that side of that parallelogram, and the height is perpendicular there. So base times height is going to be 13 times 9. And I'm going to use my calculator here to be careful. 13 times 9 is 117. So that's the area, but that's not what the question's asking us. The question is asking us to find this length of DE. Well, notice that this could also be considered a base. So this 117 could be thought of as 9.4 times DE. And so now to find the answer here, we just need to take 117 divided by 9.4. Again, I'm going to use my calculator here, and I get that DE is approximately 12.4, and that'd be inches. All right, the other formula for section 10.1 is the area of a triangle, and I'm sure you're already familiar with it. It is 1/2 base times height. If you're curious about the derivation of this formula, I encourage you to watch the extra video I posted in Canvas. So here we have a triangular sail right here, and we are asked to find how much material we need to make it. So area is equal to 1/2 base times height. Looks like the base length here is 13 feet and 4 inches. I'm going to convert that to, I think I'm going to convert the whole thing to feet. So that's going to be 13 4/12. Or we could even convert that a little bit further. That'd be 13 1/3 feet. And then we need to convert this guy as well. So the height here is going to be 12 feet 2 inches. So let's see here, 2 goes into, that'd be 1/6, so that'd be 12 1/6 foot. So our area here is going to be 1/2 base times height. So that'd be 1/2 times 13 1/3 times 12 1/6. And I'm just going to use my calculator to do that. So I'm going to do 0.5 times 13 1/3 would be the same thing as 40 over 3. And then I need to multiply that by 73 over 6. And let me just go ahead and write those in here real quick just so you know where those came from. This 13 1/3 is the same thing as 40 over 3. And this guy is the same thing as 73 over 6. Again, I'm just going to let my calculator do that. And it turns out to be, do that in red, 81 1/9 feet squared. That's how much area that sail is. So that's how much area of material we need. Okay, so now we're going to move into section 10.2, and we're going to look at the area of a trapezoid. Again, this is stuff that you guys probably have already seen in middle school. So the area of a trapezoid is simply 1/2 the height times base 1 plus base 2. So there's the formula. Remember, the bases of a trapezoid are the parallel sides, and the height is the perpendicular distance between them. So if we were asked to approximate the area of Nevada, well, Nevada is approximately a trapezoid. So we're going to say that area here is going to be 1/2 height times base 1 plus base 2. And it looks like that in this particular problem, the height, which is this distance between the two bases, is 309. Base 1 is, I'm just going to use 205. And base 2 is 511. So now we can plug all these into our formula. So area is equal to 1/2 times 309 times 205 plus 511. Again, I'm going to use my calculator. There's no sense in missing these. Just make sure you know how to type things in correctly with your calculator. Enter. Holy cow. Oops, I put a plus. And I just said what I didn't want to do, and I screwed it up anyways. I knew that was a little bit much. So this is 110,622 miles squared. By the way, this is approximately, because you'll see there's a little bit of area there that's missing. So that's approximately the area. It's about 110,000 square miles. And our last formula for today, it turns out that the formula for the area of a kite and a rhombus is the same. Now, I'll let you know that you can use the parallelogram formula for a rhombus because a rhombus is a parallelogram. But it turns out that both a kite and a rhombus will use this less known. In fact, this is the only one that I think you might not be familiar with. And it's simply 1/2 times the diagonal 1 times diagonal 2. So here we're going to try to find the area of this kite. So area is equal to 1/2 diagonal 1 times diagonal 2. So that would be 1/2 times, now this diagonal here is 7, and this diagonal here is 6. So when we multiply those together, we'll get 21 meters squared. And last example here. So here we have a diamond shape, which is also what we call a rhombus. And we are given that this edge is 6.5. And we know that this distance here is 2.5. And we're trying to find this total distance. In fact, let me make this a little bit more obvious. We've got those two measurements. We're trying to find this total total area. So the area is going to be equal to 1/2 diagonal 1 times diagonal 2. Now the good news is we already know that this diagonal has to be 5. What we don't know is this diagonal. So we're going to have to use the Pythagorean theorem. So we've got to do 2.5 squared plus, and I'll just call it x squared, equals 6.5 squared. I'm going to go ahead and use my calculator again. We're going to do 6.5 squared, and then we want to minus 2.5 squared. And that turns out to give us that x squared is 36. So x has to be 6. So if this is 6, then this diagonal total has to be 12. So we're going to do 1/2 times 12 times 5. And so that's going to give us a total area of 30. What are the units here? Feet.